So now we will proceed to the next part, which is graphing the second absolute value function. So like what we did for the first one, we will again look at the transformation from this to this absolute value function. So again, we start with the vertex at 0, 0. So if we compare the two equations this time, we will notice that the value of x change and the value of y also change. Unlike in the first absolute value equation, all transformations involve x. But in the second one, the transformations involve both x and y values. So how did I know that? So we see that here, from x, absolute value of x, it became absolute value of x minus 1. So the value of x, okay, was reduced by 1. So all the values of x will be reduced by 1. And also, the result of this, okay, we will 4 minus the result. So the 4 suggests a change in the value of y. Okay, so that means, since it's both, this is minus 1, and this is 4 minus that, so both are translations. So this is a horizontal translation, while this is a vertical translation. So how do we draw those? How do we draw the graph now based on those transformations? So from 0, 0, let's start with the horizontal translation. If we remember from Pure Maths 1, if the transformation involves vertical and horizontal, the order doesn't matter. Okay, so this time I'll start with horizontal translation. So from 0, 0, the vertex will move by 1 unit to the right because of the minus 1. So x minus 1. So 0, 0 will go to 1, 0 because of the minus 1. Okay, we are currently here because of this transformation. And then, from here, if you notice, there is a minus in front of the absolute value. Okay, so instead of a V up, it will be a V down. Again, why? Why V down? Because negative of this absolute value. So we will have a V down. However, okay, I will draw it lightly first, because this is not the final graph. Okay, this is not the final graph. Because there's another transformation involved. Okay, so lightly. Okay. So basically, this is the graph of negative absolute value of x minus 1. Okay. But we have a 4 here. And the 4 is your vertical translation. So what will happen from this graph? This graph will go up. Again, will go up by 4 units. So the vertex at 1, 0 will now be at 1, 4 because it will go up by 4 units. So it will now be at 1, 4. Let's say 4 is this. Okay. So the vertex will be here. Okay, and we will have a V down here. Okay, maintaining this shape. Okay, but before I draw it, I need to get this point first. This point. Before I move it up, this is the y-intercept for this. Negative x minus 1. So just like what we did earlier, how do I get this point? I'll just make x 0. So 0 minus 1 is negative 1. So the absolute value of negative 1 is 1. So negative 1 will be negative 1. So this is negative 1 right here. So because this graph moved up by 4 units, so this too will move up by 4 units. So it will be at 3. Positive 3. Let's say it's here. Positive 3 here. So now we can draw the graph. So now I'll make it, again, use ruler, but at the moment I cannot. There you go. So these are the two graphs. If you will notice, since they are graphed on the same axis, so we can see that they have intersection points, and there are 2 intersection points for them. Let's name the one on the left as point A and the one on the right as point B. So there you go. That's the graphs of these 2 absolute value functions. Again, recap, how did we get these graphs? Okay, we looked at the parent function. We compared the 2 equations to the parent function to get the transformations. And then, once we get the transformations, we move the vertex. Once we located where the vertex is, we find the y-intercepts. Okay.